Inequalities. Inequalities are solved the same way as algebraic equations. That is, isolate the variable and always do the same thing to both sides of the equation. Let's take a look at some examples. 7x plus 4 is less than 2x minus 1. For all intents and purposes, you can treat the inequality sign as if it's an equal sign. The same principles from linear equations apply to inequalities. Always isolate the variable. So for this problem, we want to try to get the x's alone. We'll start by subtracting 4 from each side. This gets us 7x is less than 2x minus 5. Now, let's subtract 2x. Remember, we're choosing 2x because we don't want a negative coefficient in front of the variable. This leaves us with 5x is less than negative 5. Now to complete our variable isolation, we'll divide each side by 5. And now we have our answer. X is less than negative 1. If you multiply or divide by a negative number, you must switch the direction of the inequality sign. For example, solve the following for x. Negative 3x plus 2 is greater than 1. So we'll subtract 2 from each side. This leaves us with negative 3x is greater than negative 1. Now, to isolate the variable, we'll need to divide both sides by negative 3. What this means is we need to flip the inequality sign from a greater than to a less than sign. So once we flip the sign, we have x is less than 1/3. And that's our answer. Graphing inequalities. When graphing inequalities, use a solid circle if the number is included, and an open circle if the number is not included. Meaning, if the inequality sign has a line under it representing greater than or equal to, use a solid circle. If there's no line under the inequality sign, then use an empty circle. Let's use negative 5 is less than or equal to x, which is less than 2, as an example. As you can see on the graph, the point on negative 5 is filled because negative 5 is included, whereas 2 is not included and thus is marked with an empty circle. Let's try an example problem. We are given m is greater than n. In column A we have m plus 2n, and in column B we have 2m plus n. We can simplify this problem by subtracting m from column A and n from column B. Doing so leaves us with 2n and 2m. Since the problem states that m is less than n, 2n must be less than 2m, and as such, column B is greater. Let's try another. X is greater than 3y, and z is greater than 2y. Column A contains x, and column B contains z. What is the relationship of the two quantities? Let's let y equal 0. Substituting it in the original inequalities gives us x is greater than 3 times 0, and z is greater than 2 times 0. We can simplify these to x is greater than 0, and z is greater than 0. These two inequalities tell us nothing about the relative sizes of x and z. X could be 10 and z could be 5, or vice versa. We don't know. Therefore, the relationship cannot be determined from the information given. Remember that in quantitative comparison questions, the answer choice, the relationship cannot be determined, is just as likely to be the answer as the other choices. Don't be afraid to use it.